So in order to solve this problem, we want to find L, big L. We want to isolate it itself. So we're going to do it in a similar method as we did previously, where we want to try and get rid of the denominator. Now the trick here is we have an R1 plus an R2, and we need to get rid of both of those. So just like before, where if we multiplied by what's in the denominator, then it would cancel out, and then we have to multiply the other side. So in this case, though, we're going to have to multiply by this whole thing. So we're going to have to multiply this whole side by R1 plus R2. You can't just multiply by R1 and it cancel R1, and then by R2 and it cancel R2. It's got to be the R1 plus R2. Now this whole thing cancels on this side, but then when I do it on one side, I got to do the other. So I got to multiply by my R1 plus R2 on this side. And it's important to leave it in the parentheses, because really if we wanted to distribute this out, we would need to multiply that small d by both those. So now I have R1 plus R2 on parentheses times little d equals big L times R2. And now I can now I can divide by R2 to get my L by itself. I'm going to divide that by R2, and those cancel, and then what I do to the one side, I get on the other side, R2. So now we end up with our final problem, or our final answer here, which is R1 plus R2 in parentheses times D all over R2 equals big L. Where a lot of people get confused is on that first step there. That R1 plus R2 both being in the denominator really throws people off. They think that maybe I can just multiply by R1 and then the R1s cancel, and then I can multiply by R2 and then the R2s cancel. It doesn't work that way. That addition sign throws that off. If we would have had something like L times R2 over R1 times R2, then you could have done that. But because we had that addition sign in there, you can't do that. So let me know if you have any more questions on this. Thanks.